Hi everyone, this is lesson 10.3. In the book it's called Quotient of Powers property. Our goal is to understand how we can simplify problems involving division this time and exponents. Shortcut. Alright, so what we've got in front of us is four problems which we're going to have you guys do, but of course we're going to give you a start, which as you can see is all division problems. And all of these also involve exponents. So once again, we're going to write each problem out the long way and then see if you can develop a pattern with come up with a pattern, and then create a shortcut. So let's take a look at this first one. Now 2 to the 5th divided by 2 to the 3rd. Once again, what we're going to do is write out the exponents the long way. 2 to the 5th being, of course, 2 times itself 5 times over 2 to the 3rd power. And so hopefully what you're thinking about right now is something you learned in a previous class, either 6th grade, maybe 7th grade, is this idea that when you've got a division problem with nothing else but multiplication going on, that each of these 2's represents a factor, and then anytime on a fraction or a division problem that those factors are shared, top and bottom, they can be canceled out, because basically what goes on here is this 2 divided by 2 is 1, and 1 times anything is just the same number, so it essentially just disappears. So same thing here. 2 divided by 2 is 1, and essentially just vanishes, and once again here. And so what we get is 2 to the 2nd power, or since it's a regular number, we could simplify that to 4. So the question becomes, how do we do this where we get to skip the long way? So once again, why don't you guys go ahead and take the rest of these and write them out the long way. So for example here, m to the 7th should look like this. M times itself 7 times. M to the 4th, m times itself 4 times. And then even though they're not numbers, m represents some number, and anything divided by itself will become 1. Okay, so continue on here. See what you can come up with, see what you get for an answer, but then again, more importantly, how do we develop a shortcut that gets us from here to here? Okay, and prove it to yourself. Do all of these the long way, write them out in your notes, and then see what pattern you can develop. All right, so let's see what you came up with. Now this first one we did together, once again, what turned out was we did it the long way, and we got 2 to the 2nd power, which, since we could simplify it further, became 4. Then this one, we started together, but you finished up on your own. You would have had m to the 7th across the top, 7 m's, and then 4 on the bottom. 4 sets of m's would have canceled out, and we would have ended up with m to the 3rd power. Now, these two you did on your own, so let's take a look. The long way, this would have been x to the 6th over x, or x to the 1st. And these would cancel out, one factor of x, top and bottom. The leftovers would have given us x to the 5th. And then finally this last one. Now this last one was a little tricky. N to the 3rd times n times n times n over n to the 7th. And what we get here is these 3 sets cancel out, and we get n to the 4th, except n to the 4th is on the bottom. So you might have had a little trouble coming up with what to do here. Well, what comes into play is our old friend, the invisible 1, once again. Since we can't just leave the numerator blank, that we can remember that there's always an invisible 1. N times n times n times 1 times 1 doesn't change anything, so there's an invisible 1 that we bring back out so that we can write it like that. And so what we come up with is this rule, that when dividing with exponents, what we're really doing is subtracting the exponents, specifically the bottom exponent from the top exponent. And algebraically, in a textbook or some place where we see a definition, we would write it like this: x to the power of n as the numerator divided by x to the power of m on the bottom becomes that same base number x with n minus m as the exponent. Specifically, once again, the bottom exponent subtracted from the top one. So when we do example problems like this one, what we can do is we can just do this. We can subtract. So here, for example, I've got 5 to the 5th divided by 5 to the third, which gives me 5 to the fifth exponent minus third exponent, which would be 5 to the second. I'm just subtracting the bottom exponent from the top exponent. And again, in this case, because 5 to the second power is something I can simplify further, I get 25. Here's another one. Now, this is like the last example here. A little bit tricky because the top exponent is smaller than the bottom exponent, but we can still apply this rule. So one way to think about it is this is h to the 5 minus 8, which equals h to the negative 3. And then this is a type of exponent that we learned about earlier in this unit, that anything to the negative exponent can be simplified further by simply, quote-unquote, flipping it and making it 1 over h to the third. Now another way to look at this is, once again, the long way, is think of it like this. We have h to the fifth on top, we have h to the eighth on the bottom, and since these all cancel out, it was the bottom that started off with more h's than the top, and so when we cancel out factors, we get h to the third, but that h to the third is on the bottom because that had more to begin with right here. So we get 1 over h to the third. So either way you look at it, you can use subtraction and then apply our rules for negative exponents here, or you can still picture it in your mind the long way, that since there are h to the fifth, or 5 h's on top, and h to the eighth, or 8 h's on the bottom, that when you cancel things out, you'd end up with the leftover h's on the bottom. All right, and then finally this one, g to the ninth over g to the fourth. We subtract the exponents, top minus the bottom, and we get g to the fifth. All right, so this is the key to dividing when dealing with exponents. We take the top exponent minus the bottom exponent, and we rewrite the problem with the same base number and our new exponent.